Okay. Yeah. Hope my screen is visible. So again, so we talked about venting systems and loading, unloading. Then a scheme of testing protective devices should be made by the competent person with a due regard to local conditions, the consequence of failure, duplication, fail-safe provisions, and also risk of physical damage. So how the protective devices are testing? So as I mentioned, safety relief valves and SRVs or PRVs, pressure relief valves. Those has to be tested by the competent person, and also in case of a failure. So what will be the consequences of failure? What is the secondary set of arrangement we had? Basically, for the SRVs, we have rupture disc will keep above the SRVs. I mean safety relief valve. In case the safety relief valve fails to activate, then this rupture disc will activate, and the chemical or the complete reaction mass will go to the tanks. And also fail safe provision and also risk of physical damage. So this also we have to assess in case of any failure, what will be the physical damage which can lead. Then preventive conditions based on maintenance schemes should be established, how we can prevent all these incidents by the proper maintenance, etc. And the plant should be periodically and appropriately inspected and tested. The vessel should be reassessed for the continued use with the particular contents and also safe working limits. So when I say particular contents, like different types of chemicals, and also all the plants has to be the machines or equipments has to be inspected on periodical basis. Okay. Also safe working limits, I mean their capacities. When I talk about safe working limits, the pressure and temperature confirmed or revised. Pressure limits should be revised if the thickness is found reduced, and also certification should be specify safe working pressure, vacuum temperature, load, and also fill ratio, where the content may expand with temperature rise, and also date of next examinations. It is nothing but for the basically for the vessels we do UT, ultrasound thickness. Okay, there we can understand the reduction of thickness of the walls of the vessels. Based on that, the competent person has to redefine or specify the reduced safe working pressures or the temperatures, etc. Okay. Then pressure vessel should be inspected as per the statutory requirements. The date of next inspection should be certified by the competent person. So it is as usual. Once they do the inspection, definitely they will do the write the next examination date, or we can also call it as due date of next inspection. That also they will clearly mention. Then pipelines, pumps, and also auxiliary equipment should be periodically inspected and maintained. Color code should be followed. Where failure can be hazardous, standby equipment should be provided. So wherever you have a chance of failure of equipments, there you should have a standby. For example, especially for the scrubbers and the chemical transfer units or the storage vessels, where you have standby pumps. Okay, diesel driven fire pumps or scrubber pumps, and also standby power generators. These are the some of the examples for the standby equipment. The emergency procedure should be available in case of pump or equipment failure. So in case of failure of that equipment or pump, so what will be the next course of action? It should be readily available. And modification to the plant and equipment should be of standard and also original integrity. Otherwise, the plant should be downrated, and the modification should be tested and also certified by the competent person for the use and also ability. So any modification happens, it should be on standard process. So based on your requirement, you should follow the proper requirements. Especially if you do any modifications on the boilers or any pressure vessels, you will get the PESO authorization. Before modification, you have to send in a letter along with the modification request to the authorities. Based on acceptance of their letter, then you do specific modifications. That's what is mentioned. The modification should be tested and also certified by the competent person for the use and ability. Once it is modified, they will cross check. Then only you are supposed to use. Then all the process deviations which may affect the plant in relation to loss of contaminant should be scrutinized, and also the occupier's competence to prevent the losses should be technically appraised. Such deviations concern process chemistry, pressure, temperature, flow, liquid level, viscosity, surface tension, pH, moisture content, contaminants, presence and also absence of air, oxygen, inert gases, etc. So here you have to look for loss of containments should be scrutinized. It means you have to inspect where we have this containment losses. Accordingly, you have to check for other technical parameters also. Okay. Sorry. Okay. Then training can be do little to anticipate these errors, but a good process design can minimize their effect and also ensure that no single mistake will capable of causing catastrophic. Or effective supervision checklist and also work permit system can reduce the incidence of errors. So training only will give the a little impact apart from the good design of the system. So training alone or PPs alone can't help us. So you have to, the process should be in a good design, or you should have proper safety controls in place. Then over the training will give the better results. Okay, we should have proper supervision also should be in place, and also checklist and also work permit systems to avoid the errors in case of you're doing any works for shutdowns or etc. Then causes of pressure rise or failure of pressure protection or regulating system, temperature rise, exothermic, runaway or poly immersion reactions, backfeeding of reaction, mass into the storage vessels, etc. It can result in fire, explosion, or toxic release. Okay, these also need to be verified. Causes of pressure rise or failure of pressure protection, how your relief systems can failure, how your non-return valves can failure, how the temperature will rise, how your utility system will failure. All these things we have to cross check. Then causes of temperature rise or failure of the heat controls. So how it is temperature rises? So if you are not able to control the process temperature, automatically it rises. The heating control failures, it will rise. Or failure of cooling systems, fire exothermic reactions, or it may result in the rise of pressure, flow rate, or filling ratio, forming of the foaming of the vessel content, or rollover, irreversible metallurgical change to the vessel, or it needs immediate venting or dumping. Okay, the temperature rises because of failure of the cooling systems, fire or exothermic reactions, etc. It will be resulting in increasing of the pressure. When I say temperature rises, automatically the reaction rate doubles. When the reaction rate doubles, the temperature of the chemical will rise, resulting the pressure also increases, filling ratio increases, the foaming starts in the reaction, then irreversible metallurgical changes. So the vessel also sometimes change the shape of the vessel. Or basically, for such kind of situations, we should be ready with the immediate venting. We can able to take out that chemical from the reactor or dumping. Okay. Then causes of level rise or failure of overfill prevention devices. How the level rises? So when I say overfill devices, it is nothing but an sensors. It reaches to a certain height of the vessel. It should stop the pump or the flow. The overflow device, level control devices, communication between operators, misrouting of the process teams, Steepening the loss of the vacuum or pressure, surging, etc., may result in the overflow. Then cause of flow rate deviations like too high, too low, or reverse. These are the, as I mentioned in our first session, the HAZOP. These are the guide words. Low, high, or reverse, or as well as. Sometimes other chemicals also can come and mix with this. Or changes in the differential pressure failures, or the fusing up of the pumps or pipelines or auxiliaries, loss of pump prime or vapor locks, operator errors, etc. Okay. The criteria for investigation include sizing and location of the pipes, pumps and vents, flares, etc., isolation valves, gravity, discharges, flexible connections. These are the things we have to cross check. And this type of processes deviations are many, and so are their effects. Inspection process or checklist should pay the due attention on them. So these are the various failures